I'm going to tell you a little bit about our modeling the greenhouse effect activity that we do with our students. For it, you're going to need some thermometers, 3 different tanks, some saran wrap, heat lamps, and then you're going to need about 200 milliliters of vinegar and 30 grams of baking soda. Now that's how much I use with the size tanks that I have here, which are relatively decent sized tanks. If you're doing it in large beakers or some other type of container, you might want to play with those amounts. So we've got 2 tanks that have nothing in them. One's covered, one's not. We add the vinegar and baking soda to the 3rd tank, and then you want to wait about 30 seconds to a minute before you put the saran wrap on top here. That lets the carbon dioxide be produced, it lets it push out the regular air, and so hopefully we capture as much as we can. When you put the saran wrap on, I recommend taping it down. It just helps keep everything nice and secure as students are measuring it and maybe moving it around a little bit. You don't have to worry about it so much. The other big key feature to this setup is you need to set it up ahead of time because the vinegar and baking soda reaction is endothermic. And so you want to let that sit for a little while, say 30 minutes at least, possibly over an hour, to let the temperatures equalize out a little bit. So I'm going to let these sit and then I'll come back to you. Let that sit and they have balanced out very nicely. These 2 are both at 23.0 degrees Celsius and this one's at 22.8. So they're close enough now that if the students measure, we're going to be able to see the differences and get those going. So now we're going to turn on the lights. And at this point, once we get the heat lamps on, it's again an activity where it's going to sit for a little while. This is a good time to do an activity or do a discussion of what is the greenhouse effect, to kind of explain it in words, have the students take some notes on it, so then they can later understand really what's happening here. And that's one of the really useful things that we've seen, is this gives the students the ability, if you have that piece later where you say, okay, these are our tanks, here's our earth, how do these relate to this? I like to have them draw it. I think that's a good way to get an idea of what's going on in their heads. I usually have the students record the temperature about every 5 minutes or so, but you really want to do this for at least about 30 minutes. So at this point, I'm going to go ahead and just let these sit. I'm going to go get some grading done, and we'll check back in 30 minutes. So it's been about 30 minutes. One of the things that's nice about having the kids measure about every 5 is the tanks don't necessarily all go up in a very even fashion. And in fact, a lot of times the first tank will kind of heat up the fastest because it's open, and so the kids will sort of be like, oh, what's happening? So I always like that sort of cognitive dissonance. But after about 30 minutes, you usually start to get good results. Sometimes it takes a little bit longer than that. So I've had good luck also with other classes measuring from one class to the next class to the next class. But at this point, it's been 30 minutes, and we're at 30 degrees Celsius, 29.2, and 30.6. The last thing I'm going to say is I really recommend using digital thermometers with this. If you're using just a good old-fashioned, regular, hold it up and read it thermometer, it's going to be difficult to see differences of 0.6 degrees Celsius. So I think that's kind of one of the last tips I'll leave you with. And then the only other tip I'd say is really, really take that next step to help the kids connect this to what's happening in our atmosphere. What does the saran wrap represent? They really don't always make that connection that the saran wrap is the atmosphere itself. The first is if the Earth didn't have an atmosphere. We heat up fast, but we lose heat. It tends to balance out. This one is with an atmosphere. We have something that's trapping the heat, and this one is trapping the heat, but also has increased greenhouse gases, and so it traps more of the heat. All right, I hope you enjoyed the little video lesson that we just did, and I hope you get to use this and find it useful in your classroom. Bye.